Welcome to homework.
We're asked to find a formula for an iterated function and to find the value of a certain part of this function. So this is a strange function that we're given. So we're given that fn is a function from the set of real numbers, or positive real numbers, to some other set of real numbers. So we have that fkn is defined to be n if k is equal to 0, and f of fk minus 1 of n if k is greater than or equal to 1. And we're given that fc star of n is defined to be the smallest non-negative k, such that f of k n is less than or equal to c. Where c is just some positive real number. And we're going to let f of n be n minus a. A is some positive integer. Then it follows that f0 of n is simply going to be n by definition. f1 of n is, by the recursive definition, f of f0 of n, which is f of n, which is n minus a. f2 of n is, by the recursive definition, same as f of f1 of n, which is equal to f of n minus a, which is n minus a minus a, or n minus 2a. And so we might guess that in general, fk of n is going to be n minus ka. So we found a formula for fk of n. We want to find the value of f star 0 of n, where n is a positive integer. So recall that f star 0 of n is the smallest k element of the positive integers, such that fk of n is going to be less than or equal to 0. Now, we found that fk of n is equal to n minus ka, and so it follows that n minus ka has to be less than or equal to 0. Therefore, we have that ka must be greater than or equal to n, where that k must be greater than or equal to n over a, since a is positive. And so it follows that the smallest integer satisfies this is going to be the ceiling of k here, or k is going to be the smallest integer, which in this case is the ceiling of n over a. Of course, if n over a is a integer, it's just n over a, and then if it's not an integer, it's the next integer above. So it follows that f star 0 of n is equal to the ceiling function of n of a.